Today's topic is one that almost everyone has heard of, but almost nobody can explain in plain English. RAG, Retrieval Augmented Generation. You've seen the acronym everywhere. Microsoft announcements, AI conference talks, blog posts. But what does it actually mean? And more importantly, why should you care? Here's the thing. Large language models like GPT-4o are powerful. They can write essays, summarize documents, even generate code. But they come with two big problems. First, their knowledge is frozen in time. Ask ChatGPT about something that happened yesterday and it has no idea. Second, these models never saw your company's internal data, your policies, product details, customer emails. So when you ask an LLM a question about your business, it's guessing. So that's where Retrieval Augmented Generation comes in. RAG isn't a new model. It's not a bigger or better GPT. It's a different approach entirely. Instead of asking the LLM to pull answers from its training memory, RAG first looks up the right information from your own data and hands that information to the model alongside the question. The model then uses that context to give you answers grounded in real, up-to-date content, not guesses. Without RAG, your AI works from memory that's months or years old. With RAG, it works from your actual documents right now. That's the difference between an AI that sounds confident but might be wrong and one that shows you exactly where it got its answer. Here's what we'll cover today. First, we'll look at the two problems that make RAG necessary. Then we'll break down what RAG actually is, the retrieval, the augmentation, the generation. Next, we'll walk through the key Azure services, Azure AI Search, Azure OpenAI, and Azure AI Foundry. And we'll finish with a real example so you can see how the pieces fit together. Let's start with the problem itself. Once you see that, the solution becomes obvious. The two problems LLMs have. So what's wrong with large language models? Two things, actually. First, their knowledge is frozen. Think about it. When GPT-4o was trained, it learned from a snapshot of the internet that's now months or years old. So it doesn't know about new products, recent regulations, or yesterday's news. Ask it about a policy change from last week, and it has no way to know. That information simply isn't in its training data. Second, LLMs never saw your private data, your internal documents, customer emails, proprietary databases. The model has zero access to any of that. So when an employee asks about your specific business processes, the model can't answer. It doesn't know what you know. Some people think fine-tuning solves this. You take the base model and train it a bit more on your own data. But fine-tuning has its own problems. It's expensive. You're paying for GPU time and engineering effort. It doesn't fix staleness. Once you fine-tune, the model is still frozen at that point in time. And it can't handle data that changes frequently, like inventory levels or pricing. Fine-tuning is like teaching someone a textbook by heart. Useful, but they still can't look up today's newspaper. The real solution is simpler. Give the model access to your knowledge at the moment it needs to answer, instead of trying to cram everything into its memory. Don't make it memorize everything. Let it look things up in real time from your actual data. That's what RAG does. Simple idea, but it changes everything. What RAG actually is. So here's RAG in one sentence. Instead of asking the model to pull an answer from its training data, we first go and find the relevant information, then feed that to the model alongside the question. That's the core idea. 3 simple steps: retrieve, augment, and generate. Let me give you an analogy. Think of a librarian. You walk into a library and ask a question. You wouldn't expect the librarian to have memorized every book, right? That would be ridiculous. Instead, you ask them to find the right book, open it to the right page, and read you the answer. The librarian doesn't memorize a thing. They retrieve first and read second. And that's exactly what RAG does. Retrieval first, generation second. So here's how it actually works in practice. A user asks a question. The system then searches a knowledge base. Your documents, your data, your private information. Whatever it finds gets fed into the large language model, and the model generates an answer based on that context. And here's the part that matters. The LLM never sees your raw data. It only sees what the retrieval system hands it. That's not a drawback, so it's a security feature. Your sensitive documents stay in your own storage. At query time, the model only gets the relevant snippets it needs to answer that specific question. No training on your data, no memorization, no leakage. Your data stays where it belongs. So RAG solves both problems we talked about earlier. Stale data, not an issue. Your knowledge base stays current. Private data, the model only sees what you choose to retrieve. It's like giving the librarian access to your filing cabinet, but only letting them pull out the one folder you need right when you need it. Vector embeddings and semantic search. Now you might be wondering how that search actually works. It's not about matching keywords or running a Ctrl+F across your documents. It's something much smarter. It's called semantic search, and it runs on vector embeddings. Let me explain what an embedding is. A vector embedding is a long list of numbers that captures the meaning of a piece of text, like coordinates on a map. Every document gets its own coordinate on that map of meaning. When you ask a question, the system turns your question into coordinates too, and then finds the documents that are closest to it. The key here is semantic. It's not about finding the exact words, it's about understanding concepts. If you search for budget hotels, the system can find documents about affordable accommodations, even if those exact words never appear. Why? Because the meaning is close. The embeddings for budget and affordable sit right next to each other on that map. A special small model, like Azure's text embedding 3 large, creates these embeddings, It's not a giant language model. It's a focused tool that does one job: turn text into those coordinate numbers. This is what makes RAG so powerful. Your documents get converted into embeddings once during indexing. Then when a query comes in, the system finds the most relevant content in milliseconds. Even if the user's exact words never appear anywhere in the documents, it understands intent, not just the keywords you type. Azure AI Search, the retrieval engine. So now you understand the concept. Retrieve first, then generate. But where does all that retrieval actually happen? That's where Azure AI Search comes into play. Azure AI Search is the service that stores, indexes, and retrieves your content. Think of it as the filing system for your RAG application. It handles two main tasks, and let's walk through them. First, indexing. That's getting your data ready to be searched. Second, searching. That's actually finding the right content when someone asks a question. Let's go through the indexing process first. You start by pointing Azure AI Search at your data source, which could be a blob storage container full of PDFs, a SQL database with customer records, or any number of other sources. The service reads those documents, breaks them into smaller pieces called chunks, creates vector embeddings for each chunk using that embedding model we talked about earlier, and stores everything in a search index. Think of the index as a giant, highly organized catalog. Every piece of content gets a unique ID, a chunk of text, and a set of coordinates on that map of meaning. Now the searching process. When a user asks a question, AI Search converts that question into a vector using the same embedding model, then scans the index to find chunks whose coordinates are closest to the question's coordinates. It returns the top matches, usually the 5 to 10 most relevant ones, and does all of this in milliseconds. You get a few strong options here. Pure vector search finds content by meaning, so similar concepts show up even if the exact words don't match. Keyword search works like a traditional search engine, finding exact word matches. Or you can use hybrid search, which combines both approaches, and that's usually the best choice. There's also something called semantic re-ranking, which takes those initial results and resorts them based on how well they actually answer the question. It's like a second pass that catches things the first one might have missed. One thing you should know: Azure AI Search can get expensive. The basic tier starts around $75 a month and climbs from there. If you're just experimenting, use the free tier or make sure you delete your resources when you're done. For production use, though, the cost usually pays off. You're buying speed and reliability at scale. Azure OpenAI plus AI Foundry, generation and orchestration. So now your data is indexed and ready for retrieval, but the LLM still needs to understand your question and generate a solid answer. That's where Azure OpenAI and Azure AI Foundry come in. Azure OpenAI provides the actual language model, GPT-4o, GPT-4.1, or whatever model you choose. This is the generation engine. It receives a prompt that includes both the original question from the user and the context that Azure AI Search retrieved. The model reads through that context and produces an answer based on what it finds. Now, you can't just dump everything in and hope for the best. You need a system prompt, a set of instructions you give the model upfront about how to behave. You tell it to use only the provided context, to cite its sources, and most importantly to say, "I don't know," if the relevant information isn't in the retrieved documents. That's what keeps the model honest. Without a good system prompt, the model might fall back on its training data, or worse, make something up. So how do you actually wire all these pieces together? That's where Azure AI Foundry comes in. It's the portal where you create a project, deploy your models, connect your data sources, and test your agent. Think of it as the control center for your entire RAG setup. Inside Foundry, you can add your Azure AI Search Index as a knowledge source to your agent without writing custom code for the basic setup. You just create a connection, select your index, and the agent can start querying it automatically. The portal handles the orchestration. When a user asks a question, the agent knows to call AI Search, get the relevant chunks, and pass them to the LLM along with the original question. Here's a concrete example. In one tutorial I came across, someone built a movie recommendation agent using a Netflix dataset. They uploaded a CSV file with movie titles, descriptions, and cast information to Azure Blob Storage, then used Azure AI Search to index that data. In Azure AI Foundry, they created an agent with GPT-4o and connected the AI Search Index. When a user asked, "I like thrillers, give me some recommendations," the agent searched the index, found thriller movies from that specific dataset, and returned recommendations. And here's the key: it only recommended movies that were actually in that dataset. It didn't invent anything, didn't pull from its training data, and worked exclusively from the content they provided. That's the power of RAG. Classic versus agentic RAG. Now, let's talk about setting this up. There are two main patterns, classic RAG and agentic RAG. Which one you pick depends on what you're building. Classic RAG is the straightforward approach. One query goes in, one search runs, and one answer comes out. Simple, fast, predictable. Think of it like walking up to the reception desk in an office building and asking for one specific file. The receptionist grabs it, hands it to you, done. Classic RAG works great for factual Q&A on a single topic like, "What's the company policy on remote work?" Or, "Show me the troubleshooting steps for this error code." It's reliable, cheap, and easy to fix when something goes wrong because the flow is linear. Agentic RAG is different. The AI agent decides how to retrieve information. It can ask multiple sub-questions, search different indexes, iterate on results, and synthesize across sources before answering. It's like having a building manager who coordinates with different departments to gather all the pieces. They don't just grab one file. They talk to HR, check records, cross-reference policies, and then come back with a complete answer. Microsoft ran their own tests and found Agentic RAG gives about a 40% improvement in answer relevance for complex questions. That's significant, but it uses 3 to 10 times more tokens and adds latency. For simple questions, that extra work is wasted. Classic RAG handles those just fine. So when do you use each? Classic for routine, high-volume queries where speed and cost matter most. Agentic for multi-step, ambiguous, or cross-domain questions where accuracy is worth the extra compute. Connection section, end-to-end example. Let's see how all these pieces fit together with a real example. Imagine you're building a customer support agent for a travel agency called Marigold Travels. You have trip brochures, hotel reviews, and policy documents scattered across your organization. You want customers to ask questions and get accurate answers based on your actual content, not generic guesses. Step 1. Store all that content in Azure Blob Storage. Brochures in one folder, reviews in another, policies in a third, just files in a container. Step 2. Use Azure AI Search to index that data by running the import data wizard, pointing it at your blob storage and letting it work. The service reads every document, chunks them into pieces, creates vector embeddings, and builds a searchable index. The whole process takes a few minutes. Step 3. Go into Azure AI Foundry and create an agent. Deploy GPT-4o as your model. Write a system prompt that tells it to use only the provided context and cite its sources, then connect your Azure AI search index as a knowledge source. A few clicks and it's done. Now a customer asks, what's the best reviewed hotel in Dubai under $300? The agent takes that question and sends it to Azure AI Search. Azure AI Search converts it to a vector and finds the most relevant chunks from your reviews and brochures. Those chunks get passed to GPT-4o along with the original question. The model reads through them, identifies the top match, and generates a response with citations pointing back to your source documents. Here's the thing, the LLM never memorized that data. It never trained on your hotel reviews. It works from your specific content every single time. Add new reviews tomorrow and the answers update automatically. Remove an outdated brochure and it stops showing up. The model doesn't need retraining. It just needs the right retrieval layer. So how do you actually start building RAG on Azure? Let's break it down into 3 steps. First things first, know your data. Before you even pick a service, figure out where your content lives, how it's organized, and who should have access. RAG lives or dies on the quality of your data. Next, keep it simple. Don't overcomplicate the setup. Use the import data wizard in Azure AI Search to index just one set of documents. Test with basic queries. Make sure your retrieval works perfectly before you add the LLM. Most RAG failures aren't model problems, they're retrieval problems. Last step, add the LLM. Once your search is returning the right results, then you layer in generation. That's when you connect Azure OpenAI and write your system prompt. Here's the thing, RAG isn't something you buy, it's a pattern you build. Azure gives you the pieces, storage, search, models, and the glue to connect them. You just need to put it all together the right way. If this helped you see the big picture, hit subscribe for more plain English breakdowns. Drop a comment with your RAG use case. I'd love to know what you're building.